In this video, we're going to explore how to use image sprites and the ball and the canvas to make an interactive learning game. This is very similar to Mole Mash and also the Ladybug Chase games that are in our book in chapters 3 and 5. Now, I like to make my own examples for two reasons. Number one, I respect the copyright of the person who wrote the book and don't want to just duplicate what they did. Number two, I want you to have multiple ways to learn. So you can use my examples as one way and the book's examples as another way. And so I have to be honest, as a programmer, I typically don't think about games and things where you're moving things around on the screen. I think about, I want to get data, I want to capture data, I want to send data to a certain central location. That's what I tend to think about. So I struggled with how to demonstrate image sprites and balls and canvas in an app that would be different from what the book had. And this week I had lunch with a former student of mine who was a PhD in chemistry. And one of the things I really like about programming is when you combine two disciplines together, you find that creativity increases exponentially. One of the things I recommended to him, he was kind of looking for like a project to work on. One of the things I recommended for him was making a learning chemistry game, and I mentioned AppInventor and how it could be an easy thing to do here, and also my own history, which is I started off as a chemical engineering major and quite frankly failed out of it. Then became a programmer, then much later in life took courses in horticulture, which is essentially biology, and what I learned was something really interesting, and that is that chemistry is the programming language of life. And if I looked at it that way, gosh, 23 years ago, I guess, when I took chemical engineering, I probably would have done a lot better at it, to be honest with you. So, in any case, I digress. What a ball will do is it allows us to drag it around, okay? An image sprite is similar, but a ball, it basically, the difference is that a ball is predefined as a circle. You can change the radius and the color and everything like that. Where an image sprite, you can use your own image. So over the course of this video series, we're going to use both of these techniques. In this first simple video, we're going to focus on the ball. So what I want to do, first of all, I'll start this over. Let me just delete what I have, and so we can start this over. I have just a simple app with a screen. Let's rename, well, let's see, I don't think it'll let us rename. All right, fine. Yeah, that's fine. Okay, I don't think it will let us rename just this screen one. That's okay. No worries. So let's grab a canvas. I'm going to drag the canvas onto the screen. Height, we're going to say fill parent and okay. And width, again, we're also going to say fill parent and then okay. Okay, so this gives us a place where we can put our image sprites or our ball. And so what I want to do, so again, as one who tried to take chemistry many years ago and flunked out of it, I did a bit of research here. And I probably learned more about chemistry and horticulture than in chemical engineering, and really enjoyed it, to be honest with you, the second time around. But nonetheless, the Chan elements are generally what we consider the elements that are essential to life. There's another acronym called C. Hopkins Cafe, and that represents both the macro and micro elements that you'll find in life forms, animal and plant. But Chan is a simple one to start with. So carbon, hydrogen, nitrogen, oxygen, and we see we have colors here, kind of a black and maybe a pink and a red and a blue. So let's use those. What I'm going to do is I'm going to go to the ball here, and I'm going to drop it, but we want something a little bit bigger. Let me give this a radius of 8. Everything else looks good. So we're going to make the black ones our carbon. I'll maybe drop a couple of these out here, a couple carbons out here. So I'll grab another ball, and we'll give that also a radius of 8. Okay, hydrogen is pink. Let's see if we can come up with something that's kind of pink. So, yeah, there we go, pink. Okay, and again, we'll make it a little bit bigger, make it easier to click on. And frankly, I can copy and paste. So I'll copy this guy, and we'll paste. Oh, well, didn't work so well after all. Well, let me do it here. Probably not. Okay, so no problem. So we'll just grab another one, and we'll make it pink as well. And I'll tell you what I'm going to do. I'm going to go ahead and I'm going to make the nitrogen red and the oxygen blue. But I'll pause the video so you don't have to watch me do it. We'll be back in just a moment. And now you see I have a selection of the different elements, carbon and hydrogen and nitrogen and oxygen. Now, you've heard me say before, if you're going to program against a variable, it's best to rename it. So I'm going to rename this one. We're going to make this one oxygen 3. Okay? And I'm going to go ahead and rename the others. But again, so you don't have to just watch me rename 9 different objects. I'll pause the video, be back in just a moment. Okay, now you see that we have them all named carbon 1 through oxygen 3. Now, in this simple example that we have, we're just going to consider 2 of these elements connecting with each other. So in other words, if I were to take an oxygen and add it to an oxygen, we would have O2, or what we consider breathable oxygen. If I added a carbon to an oxygen, we would have carbon monoxide. Plenty of other combinations that we can have, but for the simple example, we're just going to consider 2 collisions, or a collision between 2 of these elements. What we'll do in our next video is we'll have an image sprite, which is a little box, and we'll be able to put multiple elements in, and then we'll also be able to make some kind of quiz. But for now, for the simple example, let's just consider collisions between 2, specifically oxygen and oxygen, or oxygen and carbon. So I'm going to go to the blocks view, and I'm going to take carbon 1, and we see there is a when carbon 1 collided with other. Okay? So what I'm going to say here, we'll add a logic. Actually, sorry, we'll add a control. I'm going to say if, and then we're going to think about how we can determine if carbon collides with oxygen. Well, what we can do is we can use a control element. So we will use a comparison. Okay, you see we have this equals comparison here. So let's say if get other, whoops, almost have it there, almost, a little tricky. Oh, see, every time I give up, then it comes. Oh, okay, there we go, finally. If get other, and then what we need to do is we need to go down, let's grab one of our oxygens. Let's grab oxygen number 3, just kind of as a proof of concept. So oxygen number 3, to see if they're equal, I just grab this little dude on the end here that basically represents that oxygen number 3. Now we do need to consider the other oxygens as well. We can easily append those together with an OR. Let's just make sure it works first. Now, one other thing I'm going to need, I threw a notifier on the screen off camera. So the notifier will allow me to put a little like pop-up. So let me grab the pop-up and I'm just going to show alert. And the alert, there we go, that's in the then part. For the alert, I'm going to go to text and we're going to grab a text literal and we're going to say carbon monoxide. Okay, carbon monoxide. Okay, got it. One more thing we need to do. Let's go to carbon 1 and let's make him movable. What we need to do with that is we need to say, okay, when it is dragged, so when we drag carbon 1, we need to move carbon 1. So I go back to carbon 1 yet again, and we're going to find the move to. So we're saying when we drag it, let's go ahead and move it. Move it to the current X, which is the position at which it was dragged. Okay, well, I'm getting tricky getting my, there we go, get current X. Okay, and current Y will do the same thing. So we specifically, in this case, we want to make sure that carbon 1 is shaking hands with oxygen 3. So just to make sure we have them right, that's carbon 1. Oxygen 3 is this guy over on the right. Let's go ahead and save the project. And let's see how it looks in the emulator. Okay. So take them away just a minute. I had them rearranged from earlier. Okay, now let's have them introduce each other. And take a look, carbon monoxide. So sure enough, when these 2 molecules come together, we call it carbon monoxide. Very straightforward. Okay, for the OR, it's going to be a simple logic exercise where we have proven out that this works. What I need is I just need a nested OR structure. So let me take this widget here. We can do this fairly quickly. Control C, Control V, Control V. Okay, oxygen 3, we're going to make one of them oxygen 2. We're going to make the other one oxygen 1. So this carbon 1 just needs to collide with any of our oxygens. We're going to need to do a little bit of nesting here. So in other words, a bunch of ores put together. It's going to get a little bit long, but we'll manage. Okay, then this guy, if we can snap him, let's maybe need to put, Control Z. Whoops, hang on one second. Okay, looks like I pulled him to the wrong place. We'll get that fixed. Okay, now drag this guy up here and drag this guy over here. So we say if it collides with either oxygen 3 or oxygen 2. Now let's add yet one more ore to make it really nested here. Let me just drag some things around to get it to fit. Okay, I'm going to add an ore for oxygen 1. Okay, and now I'm going to take the big ore with oxygen 3 and 2 and put it in this new ore. So see, we can nest ores. I know this looks a little bit goofy, but we're saying if the other is oxygen 3 or oxygen 2 or oxygen 1, then we're going to pop up a message about carbon monoxide. Now we just have to take this guy and get him all put together. Okay, so drag and drop. There we go. Not bad. Okay, let's give ourselves a little bit of space here. Okay, so go ahead and save. Okay, and go back and let's see what happens now. When we put it together with any oxygen, I drag them out and then I make them collide with another oxygen, carbon monoxide. Okay, very good. We can do we can do the same thing with oxygens as well. We can pick one of these oxygen molecules, and you see right now they don't move because I haven't told it to move. But I can go ahead and do a handler for one of those. So let's go ahead and grab our friend oxygen 3. And what we really should do is we really should reverse what we've done up here and say we can combine oxygen 3 with carbon 1 instead of carbon 1 with oxygen 3 and get the same result. We could do that, but you see the problem is we're eventually going to need to wire up every relationship possible between each one of these molecules or each one of these elements. That's going to get out of hand quickly. So that's where the next video might be a little bit better, where we just put them all together in one image sprite and then we take an inventory of what we have and say, okay, what is this? What do we have? In this case, what I'm going to do is I'm simply going to add another if structure. And I'm going to say if oxygen 3 collided with oxygen 2 or oxygen 1, then we're going to say atmospheric oxygen. So, okay, well, we know that we need an or. Okay, if, okay, and then we know we need one of these math comparisons that has the equals. We're going to need actually two of those. Basically on either side of the or, so let me give myself a bit of room. Okay, there we go. And another equals. Whoops, nope, that's fine. Okay, if, okay, one more time. Get other, snap them in one of the ors. Get other, almost. Get other, snap them in the other or. Okay, and this is oxygen 3 again. Okay, now we need to say, did it collide with oxygen 1? And we scroll down. Okay, so that will be one of our ors. And then the other or is going to be oxygen 2. Did it collide with oxygen 2? Whoops, almost there. There we go, there's oxygen 2. We'll put him in here. Okay, then call notifier. Okay, and we're going to show an alert again. Okay, once again a string literal. Okay, and we'll call this atmospheric or breathable oxygen. Okay, and that's important, so we'll put an exclamation there. One more time, I'm going to need to duplicate this dragged event, but I'm going to need to duplicate the dragged event for oxygen 3. So easy to do. Oxygen 3, and then we're going to say move to. Okay, current X. Try to get them in there. Well, almost. Okay, and current Y. Okay, and then save, and let's see how it looks. Okay, so here's our oxygen 3. And what happens? Can we drag him yet? There we go. We drag him. Oh, there we go. Atmospheric oxygen. So I kind of sideswiped it there and got the notification. Drag him back again. Put him up to the other oxygen. And atmospheric oxygen. So in this video, we've seen how in just about 15 minutes we can very easily make a learning game. Now we probably want to add a few more things like maybe labels that describe what the colors are, because it's not apparent unless you happen to look at the Wikipedia article that I looked at. So we probably want to add a little key, which we can do in a later video. And we also want to consider how we can make it more efficient so we can combine multiple elements together. And we can also combine, we can put them kind of in one sandbox. So a few UI improvements, we'll take a look at those in our next video. Thank you.